We're here at gotomath.com. Click on the calculus button and let's go down to numerical integration. Numerical integration, because in the real world this is what you'll probably use. It says use the trapezoidal rule for approximating the definite integral with n equals 4, and here's the integral and here's the limits. Alright, so let's go to there. Okay. So here we go. We got the integral going from 1 to 7 of x squared dx. Now we're going to use a rule called the trapezoidal rule, and if you don't know what a trapezoid is, I guess I'll draw one up for you. So you should know how to get the exact answer to this particular integral here, right? So there may be a point, case in time, when there's a function there that we just can't get the integral of. Okay. Alright, so let's write that down. We're going from 1 to 7 of x squared dx. X squared dx. Bringing up the whiteboard. We're going from 1 to 7 of x squared dx. You might try getting the exact value of that. You should know how to do that. Alright, so we're using the trapezoidal rule, and the way we're going to look at this is finding the area under the curve. So I'm going to draw this curve here, get something drawn. Now this is probably not going to be to scale, so, and let's use a different color actually. We'll use red. We'll say this is 1, and we'll come over here and say this right here is 7 right here. Alright, now in the problem it said that n was equal to 4. So if you don't know what that means, basically what this means is we're gonna be approximating the area under this curve, okay, and we're gonna cut it up into 4 subintervals. 4 subintervals. Right. So let's see if I can if I can do this, try to get this even here. Okay, that looks good. 4 subintervals. 1, 2, 3. 1, 2, 3. Oh my gosh. Alright, we're going to try that again. Okay. Alright, so I need to put 3 lines in here. 1, 2, 3. We'll do 1 here, 1 here, and 1 here. This is not exactly going to be a pretty picture. Okay, these subintervals are supposed to all be equal here. And okay. Now, let's review real quick here on finding the area of a trapezoid. So here's a trapezoid. Okay. So each one of these are trapezoids, as you can see here. And this side right here, we'll say this is f of x. Normally we'd say like I minus 1, but I'm just going to say f of x naught, this side. And then this side is f of x1. And then this side right here is going to be b minus a divided by n. Now what this is right, we're going to cut, this is your a, this is your b, right? And we're dividing this up into 4 subintervals. So if we want to know this exact distance right here, right, we would take this minus this and then divide it by however many subintervals there's going to be, and there's going to be 4. Alright, so that would be this distance right here. Okay, now let me just go ahead and what you might see in a textbook or something is like, for example, this side's, now don't get this A mixed up with this A, alright? This side's A, this side's B, and this side is H, let's say. So if we're trying to actually find the area here, it would be A plus B divided by 2 times H. So this would actually be the area of this trapezoid right here, the formula to find the area of this trapezoid. Alright. But because, now like I said, this A and this B are completely different than these guys here, okay? But usually in a textbook, this is what you find for the formula. Now what's actually interesting about this formula is, I want you to think about going back to the, what was it, the average value? Remember finding the average value for integrals? Well, we were finding actually the area, the average area, I guess, this area here, because what this is, f of x naught plus f of x1 divided by 2, for example, is going to be this point right here on the line. You see this? Okay, it's going to actually be this height right here, and which is the average value. Anyway, I just thought I'd throw that in there. Okay, where are we at? Well, so we know now how to find the area of this trapezoid, right? It's going to be f of x naught plus f of x1, right? F of x naught plus f of x1 divided by 2, and then this h right here is this distance right here, which is actually, this here would be equal to h. Okay, so why don't we go ahead and find the area of this first trapezoid. Let's find the area of this first trapezoid, and we'll just call this area 1. How's that? So this will be, I should say trapezoid 1, but anyway, we'll call it area 1. Okay, now there's some things that we need to come up with first before we even get started. First off, this point right here, we're going to call this x of naught. X of naught is equal to 1, right? X of naught is equal to 1. But then what would this x value be here on the x-axis? Well, we would go 1 plus the delta x, right? 1 plus the delta x. Now, the delta x is equal to, remember, b minus a divided by n. So we need to come up with that right there, okay? So delta x is equal to, this would be 7 minus 1 divided by, and remember what n is, that's going to be 4 subintervals, 1, 2, 3, 4, okay? So this would be divided by 4, and then this all breaks down to 3 halves. 3 halves, all breaks down to 3 halves, okay? So x of 1 is equal to 1 plus 3 halves. Now you can say times I right here, and I would actually be 1. Okay, so this would be for the first subinterval. Yeah. Okay. And then we say x of 2 is equal to 1 plus 3 halves times 2, or you could think of this as the second delta x, right? This is the first delta x, and then the second delta x, third delta x, and fourth delta x. So x of 3 is equal to 1 plus 3 halves times 3, right? That makes sense. And then delta 4 is equal to 1 plus 3 halves times 4. Okay, so we got all of our delta x's here. The first one is just 1, then the second one is going to be this number. And actually, what I'm going to do here is, I got some room. Let's just go ahead and simplify this down, and this should simplify down to 5 halves. So I'll let you work on that. And then this one here, this should simplify down to 4. I shouldn't have been using red ink. And then this one here should simplify down to 11 halves. I got that right. And then delta 4, this one should simplify down to 7. Okay, so we got all of our x values x0, x1, x2, x3, and x4, which is obviously 7. Okay, if that wasn't 7, we'd be worried about it. All right, and let's go ahead and work down here. That's not a for area 1. This would be the first trapezoid, area of the first trapezoid. Okay, so to find the area of the first trapezoid, we take this height, right? Well, I guess I didn't write the formula down. Kinda. Anyway, we take this height, add it to this height, and divide it by 2. So that would be like this piece right here, right? This height plus this height, and then we'll divide it by 2. So that's going to be f of x naught plus f of x1. Divide that by 2 and multiply that by this guy here, h, or we could say this right here, right? Multiply it by this. Now we got this number right here, and that is 3/2. Okay, so, and you know what? I kind of did this generally right here, so I don't know. Multiply it by 3/2, I guess. Anyway, so let's go ahead and write equals here. Okay, so f of x naught plus f of x1 over 2 times 3/2 turns out to be 87 over 16. Okay, you're like, well, where did that number? Well, just plug in x naught here. Okay, I'm not going to do this for all of them. We'll just, I've kind of run out of room here. We'll do this right up here because I'm going to write all the rest of these down below. And I'll do this one, and then you can figure out how to do the rest. So f of x naught is going to be equal to, well, x naught is 1, right? So that's 1. And then f of x1 is equal to something here. There's x of 1. So you plug in 5/2 into our function here. So this would be 5/2 squared, right? So this ends up being 1 plus 5/2 squared. Divide that by 2. Multiply it by 1.5 or 3/2, and you should get 87 over 16. Right? You should get 87 over 16. Okay. So area 2, that would be this second area. So we're going to take f of x1 plus f of x2, divide that by 2 times that by 3/2, and you should end up getting 267 over 19. Okay, so you do it the same way, right? Take x of 1, which is 5/2, square it, plus, and then x of x2, 4 squared, divided by 2, times it by 3/2, and you get this number here. Okay, so we continue to do this for all of the trapezoids. Now, in the real world, the ideal world, you would write a computer program, and of course that's how I did it. I wrote some script to come up with this answer. So x of 3, and somewhere on my YouTube channel, or maybe even a link on this, there will be a tutorial on how to do that, and I'm kind of debating on what computer language I want to use. Of course, I write this stuff in JavaScript, but Python seems to be pretty hot. But the cool thing about JavaScript is all you need is Notepad. And then save it as an HTML document, and boom, you're done. Even though that's kind of actually hard to do if you're on a phone or something. whoa, I messed that up. That should be x of 3 plus f of x of 4, which is our last one, and then that's over 2, and then times that by 3 halves equals 951, I believe it was, over 16. Right, so the sum of the areas, you want to sum up all of these areas, is going to end up being equal to 465 over 4. Now, I think I end up writing it as a decimal place, I believe. Let's see what we got on that. 11, 116, 25. I think I end up writing it on the answer as a decimal place. So, okay. So now this is an approximation, remember, an approximation of the area under the curve. And what you'll want to do is actually take the integral of this, get the exact area, and compare them. Now that all of that is said, if you let n, right, the larger n gets, okay, that means there's going to be more of these rectangles. And the more of these rectangles, that means that this little area, like this little white space, which probably shouldn't actually be here, I don't know, becomes smaller and smaller. Okay, in other words, you're going to converge towards the exact value as n goes to infinity. That is, as n gets larger and larger and larger, you're going to get closer and closer to the exact value of of this integral here. So anyway, but writing some script is the real way of doing this, really. But we're getting a technique down on how to actually find the area. So basically, if you can just remember the formula for finding the area of a trapezoid, and there you go, you can apply it. And if you forget how to do integration, right, forget that pattern, you can always use the trapezoid rule. And if you know a little bit of script, because it doesn't take a whole lot really, you can write some script and find the area under the curve. Bam, be done. Okay, well, let's go back over to the page. Of course, I already checked that. Anyway, so we got 116.25 there for this. All right. So we spent 17 minutes on that, but hopefully you understood it. And of course, I didn't go through and work out every little detail. Hopefully you can do the basic math on that. All right, so come on over to gotomath.com, practice that, and I'll see you.